Welcome to London OpenShift Commons. So as Aubrey said, and as some of you know, I spend most of my time with security for containers and Kubernetes. That does include advocating for developers and security for developers, and how do we help them. You all also know that we are in a world of constant change. And as we work to innovate, a number of years ago, innovation was focused on microservices, container-based, Kubernetes. Now innovation is focusing more on AI-enabled applications, but we still have a huge amount of security concerns that need to be addressed. And in fact, in some ways, those are growing. So every year, since we acquired StackRox, we've done a State of Kubernetes Security report, and we're seeing some trends there. We see that 67% of companies have delayed or slowed adoption or deployments of Kube for 2 years in a row. We see that 46%, up from 37% in 2023, have actually been affected by a container or Kube security incident, and 42% of our respondents cite security as their top concern. Now, the good news for me is that in addition, we're seeing this number 48%, which is a bit different from the others, grow. This is an investment in DevSecOps, and while DevOps has always intended to include security guardrails, many teams who roll out DevOps don't do security guardrails other than vulnerability scanning. So we're going to talk with you today about all the things that are available with OpenShift and from Red Hat to help with supply chain security and with this incredibly increasing number of vulnerabilities that we're all dealing with in our industry, right? 60% increase from 2022 to 2024. Also, a strong increase in regulations. So these are just a subset of regulations that are affecting the EU. There are similar regulations in other parts of the world. Supply Chain Security, Digital Operational Resilience Act, which I'm sure a number of our customers here in this room are affected by, cyber resilience, and of course, new regulations for AI. So again, we want to help you get visibility into what's actually deployed so that you can better manage it, get the evidence you need for your auditors to show that you are meeting these regulations, address integrity, auditability, protect applications and infrastructure from attack, and then also address those software vulnerabilities and enable your teams to innovate while managing all of that. So, how do we help? We deliver security value beyond protection with business benefits as well, lowering operational cost, reducing operational risk, and increasing operational developer productivity. We do this with the OpenShift application platform, which includes enterprise Kubernetes at its core, but way more than that, right? It's a container platform, a platform for virtualized applications with OpenShift Virt, AI-enabled applications, and applications running at the edge. So these are some of the built-in capabilities, pre-hardened deployments, patching without application downtime for well-behaved cloud-native apps, multi-layered security, defense in depth with SE Linux, encryption, deployment controls, built-in compliance tools, built-in networking security at multiple levels, including new capabilities like user-defined networking that help with isolation without the need to use network policies and better supports open virtualized workloads, and threat detection and response. And Natale is going to show us some of how this works.
Thanks, Kirsten, for giving me the opportunity to show you this in practice. And my name is Natale Vinto. I do evangelism and advocacy here in Red Hat. And I'm glad to be here in London for OpenShift Commons. So let's go for the first demo. We're going to show you how advanced cluster security for Kubernetes from Red Hat help you with compliancy. How many of you deals with a PSI DSS? Not many? Some of you, right? This demo show how it's easy from ACS, showing doing a scan from your systems and doing some scheduling on the scan. The scan will get you the result, and those results are audited for all the clusters. You can see all the details on what you should fix, what are the improvements, what are the instructions to do the improvements, and what I like from here is this dashboard, the compliance dashboard, where you can see all the standards and the charts and how you can manage and export this data into a report that you can use for your convenience later. So that was our first demo, Kirsten. But now I'd like to show you a real-world example, like what about if we have to mitigate a vulnerability at runtime in production? What about if somebody, an attacker, goes into a container, running pods, and try to execute some command like installing a package?
We have an example, for instance, if somebody's trying to access a container and trying to install some package, this is inhibited by the platform. And as you can see here, there's some violation. That's why we defined a policy where if somebody's trying to access the container and install with the package manager of the Red Hat family, is trying to install a package, then there's a notification in some messaging system like Slack, and also that could be stopped at runtime. So I like to show you the example. Here's a pod, a container running in the cluster, and if an attacker or either an internal user is trying to execute, install with the package manager something, then there's an immediate alert coming up. But what about we want to stop that? We want advanced cluster security for Kubernetes to automatically stop this. Then we can go into the policy itself and into the policy behavior. We can go into the action and set like inform and enforce, and we can enforce at runtime. So when we do that, this policy has immediate effect. And when we come back to the container and we try to install the package, we will see that the pod is terminating. So this action is immediately stopped, but also, of course, informing about the issue on Slack, but is also acting.
Thank you so much, Natale. So again, we are going to, that shows some of the focus that we have on supply chain security and DevOps. Remember, DevOps should be thought of as DevSecOps, which means not just DevSec, but also SecOps. So we've just seen some of the SecOps things that are available with OpenShift, but we've also focused on capabilities that help you to secure the software supply chain. Again, that's an area where we're seeing increased regulations. So we have functionality that helps at the package selection time, when you're coding, at build, deploy, and the runtime, as you've just seen, or monitoring. But Natale's going to walk us through securing the pipeline.
Yep, here's another demo on a real-world example. Let's imagine a e-commerce application. In this case, it's a Red Hat Cool Store, a very cool e-commerce where you can have all Red Hat swags. You can see multiple microservices. We're running out of Fedora in the store, but we'll have it here, so we can give you the Fedoras. Real-world app for microservices. And I want to show you how security can be put from the beginning. We can set up all this system for security from the beginning. And this is where another product from Red Hat helps. It's called Red Hat Developer App. It's our internal developer portal product that allow you through a mechanism called software templates to scaffold applications which are secure by default at the beginning. How this is possible? Because when developers self-serve and go into the platform, they will use one of these templates. They will select, the configured secure registry. In this case, we're using Quay. Connect to the Git server. So this will be set up by the administrator, right? But developer then can self-serve. I need this microservice. I need this database. I need this Kafka. I need everything which is available in this catalog. And talking about the catalog, developers also have out-of-the-box an architectural diagram of what they're scaffolding. Here's, in the example, we were scaffolding 4 microservices. We have all the API exposed by the microservices. It becomes also an API catalog, a software catalog. And this is live. This is running on OpenShift. The software template will scaffold all the automation with secure pipeline and GitOps to deploy on OpenShift. And so that is a live endpoint. And what I like to show you here is that we're working on one of these microservices. And this microservice comes, with a software skeleton with the right dependencies approved by the companies, the right Docker file with the right base image approved by the company, and as a default secure pipeline set up with all the automation, all the GitOps entries to automate the deployment in one or more environments. Connection to the secure registry, in this case, Quay.io, dependency graph, technical documentation. So as a developer, for me, my onboarding experience is really made easier. And also the security experience is made it easier because somebody has set up a secure pipeline. You can see this is an OpenShift pipeline with several steps. One of the steps is verification of commit because another product from Red Hat called Trusted Artifact Signer is able to do digital signature on the commit side. We will see in the demo later. But as a developer, I can see all the logs of the pipeline. I don't have either to access the cluster. It's in view-only mode here. I can see the logs from the pipeline. I can see the security scan result. I can see the application running in the cluster with one of these components. And let's do an example. We work in this application. Let's imagine that for some reason from Stack Overflow, we copied this terrible dependency, log4j, the famous log4j dependencies, right? For some reason, we want to do that. Here's where Red Hat helps. We're shipping from our product called Trusted Profile Analyzer an extension for popular IDEs like Visual Studio Code, IntelliJ, that help you scanning your dependency file before sending it to the pipeline. This dependency analytics is using an open source vulnerability database. And this, of course, is saying to us, don't use it, critical vulnerability, huge mistake. You should stop here, right? And it's also suggesting what is the version that fixes that issue. And it's, of course, suggesting what is the remediation and so on. But if for some reason the developer really wants to push this, I want to show this, gives me the opportunity to show you the digital signature and the secure pipeline and also the verification of advanced class security for Kubernetes. So developer needs to sign the commit. No? Only the author can run the pipeline really, right? When you do git push, they will need to authenticate through Red Hat single sign-on on OpenShift. So SigStore is the open source software that is backing the product, right? It's signing the commit. So when the commit really arrives to the Git server, then the software template has also scaffolded some automation to kick off automatically the pipeline. So the pipeline will start. In this case, it takes a couple of three minutes. So we skip that. And we wanted to show you that the pipeline is failing because advanced cluster security for Kubernetes recognized that there's a vulnerability there. And of course, there's log4j. So we created either a custom policy called critical vulnerability stop. When the severity is critical, stop everything at build time and inform on the communication channel. Same of this previous demo on Slack. So at build time, stop, enforce, and inform on Slack. So the pipeline stopped. This will not go to any environment. And also, what I like from here is this report from ACS. As a developer, I don't have to access advanced cluster security for Kubernetes. Here I have all the suggestions. Oh, I'm violating this policy, and it breaks the build. But ACS comes with out-of-the-box policy like log4j. No? If somebody really put the wrong log4j version, there's already a policy there. It's part of the default policy available. So let's remove this crap because we don't want to add this version. And when we redo the scan again on the developer workstation, now the dependency analytics part of Red Hat Profile Analyzer is saying, OK, there's no vulnerability in your dependency file. So you're good in dependency file. But the software bill of material is a composition from dependency file and also container image files and layers. So If we redo the scan, it's good now, it's better. There are still some vulnerability, but not critical. So by a policy perspective, this is what we set up, we're good, we can send that in an environment. In Trusted Profile Analyzer, this is where you can upload your SBOM, your software bill of material. This is what the pipeline did, was uploading the SBOM. So the SBOM can be also scanned by Trusted Profile Analyzer. But you can see the SBOM file is a combination from the dependency file and the Docker file dependency. So the base image, the layer that you're adding in your container. And if you perform a scan here, you will find more stuff because, again, it's a combination of the two dependencies. This is the part where the secure pipelines really live, right? And it's I want to show you that it's not only a signature. There's also a signature of the container image, but there's also a signature of the pipeline itself. This is great for attestation and provenance. So you can make a provenance attestation for the container image, but also for the pipeline. So an attack cannot inject malicious code at build time.
Thank you very much, Natale. Awesome. So I'm curious, how many of you are cluster administrators in this room? Show of hands. So only about half. How many of you work with pipelines or develop for OpenShift? Smaller number. So one of the things we'd like to emphasize, right, we demoed with OpenShift pipelines and with OpenShift GitOps, but many of these security capabilities that integrate with the pipeline can be integrated with other pipelines. My experience has been that most of our customers have more than one pipeline in their organization. How many of you is that true for? Do you know? Fair, it's a handful anyway. Okay, so it's really important to us that we help you meet you where you are. We think Tekton provides some additional capabilities, the ability to manage pipeline as code, the ability to sign task runs, have evidence that you've done what you said you were going to do in your pipeline. But that said, we know many folks are still using Jenkins or Circle CI or other flavors, and the solutions that Natale demonstrated, right, Trusted Profile Analyzer can be integrated with your IDE, Trusted Artifact Signer can be integrated with any pipeline, ACS can also be used with any pipeline, and of course you can use the registry of your choice, whether that's Quay, Artifactory, Nexus, or some other registry. So together, right, the goal is to help shift security left, address that DevSec part of DevSecOps, help your developers to address issues earlier in the process. It costs less, back to that business value. The earlier you find an issue, the less it costs to fix it. And developers really don't want to hear at the end, just as they're getting ready to deploy, that they have vulnerabilities that they have to go back and fix. So automated deployment of a pipeline, if you get to use a solution like Tekton, again, the ability to catch not just known vulnerabilities, but misconfigurations in YAML files, requests for excess privileges. The digital signature and verification, is that something that folks here are doing with code as artifacts as they move through the pipeline? Not a few, okay. And image signatures, are you signing custom images? You are, okay. So this is something that we anticipate seeing more demand for from regulatory bodies over time, so the capabilities are there as you start to see a need for them. And multiple deployment guardrails, both in OpenShift, ACS, ACM, help to ensure that you're only allowing pods onto the cluster that meet your requirements. Also, we've added in ACS the ability to auto-generate network policies for a set of pods. So this is something that we find a lot of teams aren't sure how to work with network policies, how to build them. This is an option for doing that without having to learn a lot, right? You can sanity check, and then also once deployed, you'll have admin network policies kind of as that behind-the-scenes gate from the network security team. So, of course, we can't not talk about AI.
Of course.
Today, that is consuming the world the way software consumed the world, open source software consumed the world. So we wanted to shift gears. Those same pipeline security solutions can be leveraged with an AI/ML application. And we wanted to just sort of focus a little bit on what OpenShift is doing to enable building, running, managing AI-enabled applications, both predictive AI and generative AI. So you can bring your own model. You can also use Red Hat AI tools to build models. We can do model serving and monitoring. Has anybody here used OpenShift, Red Hat OpenShift AI? Roy? Small number, okay. So you may know that Roy supports Q. We are migrating support for Q into core OpenShift to make it easier to use those capabilities that are designed for Kubernetes with AI applications, not just with Roy, but with other flavors of AI. Lifecycle management, resource optimization, and management. And again, Natale's going to take us through some of what that looks like.
Yeah, what I like, thanks, Kirsten. What I like from this demo is that we can put all the security talking points we had in the previous demo also on an AI-powered application. In this case, we're going to do our RAG application using a software template that supports either self-deployed model. So if you have one of those models available in your cluster, as developer, you could self-serve the deployment of those models. So there's an automation for the app. There's an automation for the model deployment, and then this goes into OpenShift AI. It's OpenShift GitOps that will deploy everything and sync everything, and OpenShift AI will serve the model. So we have a software template to serve the model. Then we can create a RAG application where we can just put the endpoint from that deployment model, and then we can put the name of the model, and if any API key, if we want to filter and limit the access to the model itself, right? So as a developer, for me, it's pretty straightforward. It's a self-serve experience with what I have in the cluster. Again, it's the same view as the previous demo. No? We're going to deploy an application on OpenShift. It's one or more environment. We have some secure pipeline set up out of the box with all the vulnerability scan, code signature, image signature. We have SES checking all the policies for this particular environment, this particular app. So the same structure is valid also for the AI-enabled application. But the difference is that we are also having, the connection to the model, the deployment of the models. And there's the Python application using pgvector. We have our EDB Postgres friends here. I know you like it. And there's the connection with a query registry with the signature of the container image. And then there's an API listing here. Those are the API, inference API of the model. As a developer, I have this endpoint that I can use. I want to show you this application. If you ask to a model, what is OpenShift Commons? Of course, the model knows, because it's so popular. Any models know what is OpenShift Commons. But if you ask something like more new, like when is Kirsten's session at OpenShift Commons, the model doesn't know yet because it has a knowledge cutoff. That's why RAG approach it's good, right? Because we can add more knowledge to the model at runtime. So if we ask the model this question, doesn't know yet. This RAG application support the upload of PDFs and at runtime. So I was downloading the schedule of the OpenShift Commons of today. This is my computer, uploading, processing, feeding into the vector database. And now, if we do the same question to the application, now knows that Kirsten's session is today at OpenShift Commons. So that's a quick example on how we could scaffold a RAG application, feed information as a PDF to this app, and put also security in place everywhere.
Thank you, Natale. Awesome. So again, this is just a bit of an example of a customer who is already using OpenShift AI with OpenShift Platform Plus with some support from Red Hat Consulting. So they have more than 100 data scientists working at Deniz Bank, large private bank in Turkey. I'm not sure how I'm supposed to gather the name is changed a bit. They want to make their workflow a less manual process with a more standardized approach. And they worked with their subsidiary, Intertech, to embark on a project to provide a model development environment with automated pipelines, standards to improve productivity, time to market, and they were able to make key improvements with adopting ROI, as we call it internally, for self-service capabilities and to scale model serving and improve operational efficiency. So all of this enables the data scientists to focus on models and without having to worry as much about security. We wanted to finish with a little bit about the security roadmap before we take questions. So again, with the focus on DevSecOps, we have the ability to provide facilities that help you control application security during the build process, as you've seen. We have the ability to protect the platform at deploy time and to detect and respond to runtime issues. So for AI-enabled apps, but not just AI-enabled apps, we're focusing in 2025 on protecting data in use. So as you think about that RAG application integration that Natale showed us, we believe that organizations are going to supplement models that they're using with private data. So we want to ensure that as that happens, as there's a communication or reach out to that private data, that the data is protected not just at rest or in motion, but also in memory, because that is private data, that is intellectual property. We want to make sure, you want to make sure that that data is protected. And confidential computing and zero trust architectures help us to do that. So we have a combination. We're working on federated workload identity with a Spire operator that will be coming out in 2025. Confidential computing, we have the ability today with cloud providers to deploy confidential clusters, OpenShift clusters and confidential VMs provided by the cloud provider. We also have the ability to do confidential pods or confidential containers through bursting into the cloud provider with Kata containers. But we want to make all of this available on premises on bare metal. Because the confidential container solution relies on micro VMs, on Kata sandboxed containers, you need to be running on bare metal. We don't support nested virtualization, right? But this is a great opportunity to really work on that zero trust model, provide trust boundaries within a cluster that are defined and protected so that the admin even cannot see inside the workload. So in addition, we're of course investing in responsible AI. Trusty AI is an open source upstream project to monitor for drift and bias in AI models. For platform integrity, we'll be adding RHEL Core OS node attestation. Again, that's part of our confidential computing solution so that we can go beyond those, the cloud provider attestation to one that can be leveraged on premises. Also, Kubernetes community, we've been working closely with them for quite some time on Kubernetes user namespaces. How many of you know what user namespaces are? A few. So this allows user namespaces, which we already support in Cryo, allows a process that runs with privilege inside a container. If there's a container escape, it is unprivileged outside the container. It's been taking years. I have been talking about this and been asked about this for most of my time at Red Hat, which is almost 9 years now. And Kubernetes is finally updating the API to understand user namespaces. So one of the security questions I get regularly, in fact, I got it last night, was why do control plane components run as privilege? All kube clusters, the control plane components run as privilege. That is how it works upstream. There's been a KEP out there for years to have it work as non-privileged. The community has determined that the best way to do that is support user namespaces so that we can run those control plane components in user namespaces. So we are actively working on that. User namespace is currently beta. We're hoping it will GA this year. Post-quantum cryptography. Have you all been hearing about that from your companies? Fair amount. So we're also investing there, right? Red Hat is, there's a whole series. There's post-quantum ready, post-quantum safe, and whatever the third one is. I always blank. So the key goal for post-quantum ready is to ensure that we're using algorithms that are going to be encryption algorithms that are going to be harder to hack once quantum is more widely available. So we want to be sure that if somebody is gathering data now, they're not able to decrypt it down the road with those quantum computers. So we are actively working in RHEL 10, backporting some of this functionality to RHEL 10, also working with the Go community, OpenSSL I know that's not Go, sorry, just switching gears. OpenSSL is a big focus for us as well, and we have to be looking at increasing our signature length. 256 is deemed iffy, so we're looking at bigger than that, and a lot of investment happening there. And then another cool thing, you saw Natale show how ACS can kill a pod if there's a runtime issue. Where Kubernetes has forensic checkpointing. We'll be integrating this forensic checkpoint with ACS policies so that not only can we kill the pod, but we can capture the environment, dump the running environment to disk, offload it off that node because we don't want to leave it on the node, and then you can move it somewhere to a sandboxed environment where you can actually do forensics on what happened. That's also something I've been asked for years from our customers. So really excited to see the investment there. And also runtime analysis. You all, I'm sure, are dealing with the same large number of CVEs that the rest of our industry deals with. We're working to integrate data from runtime against the known CVEs so that rather than just a static list of CVEs that are ranked by severity, we want to give you additional info to help you prioritize in an automated fashion, right? Is that application exposed externally or not? One that's exposed externally should be prioritized higher. So we have some of that information already in ACS in the risk analysis, but we're investing more in that space and making that more visible. So that's a look at some of our security roadmap. We want to thank you for listening, and we do have time for questions. So.
Yes, can I ask you please to come here because we have set up the camera here, so you can ask on the camera as well. Thank you.
Thank you. This last thing that you mentioned is actually very interesting, but a lot of enterprise customers already have existing security solutions. And often security teams do not want to introduce another security application. So they would like to have this functionality without using the whole ACS. Is this planned to be done?
And are you particularly asking about the vulnerability prioritization?
Yes, yes.
So unlikely that, you know, there may be a point in time when we integrate some of ACS more into OpenShift platform itself. ACS is a cross-Kubernetes solution, a fleet solution. We are planning a plugin to the OpenShift console that would focus first on vulnerabilities. So from that perspective, that may be a way that you can kind of skin the cat, we'd say in the States, but where you can leverage both the security solutions that your team might already be requiring, plus this information from ACS. We do need to have it associated, like you need to have the scan data, the CVE data, and the runtime data. So one of the other things, though, that we are exploring, so how many of you maybe use CrowdStrike, for example? A few? So CrowdStrike is a fairly popular partner who also does runtime security. So integrations between ACS and partner security solutions is a potential path. And some of that is going to depend on the partner's interest and our customer's interest. So there are options, but it may take a bit to show up. It's a good question, though. Reality, right?
Any other questions in the room? Yeah.
Hey, Kirsten, we've been so we've been talking about tools a lot, and one of the kind of historical issues has been, well, developers pay attention and they know what to do, and as we've had many conversations in the past, that's been kind of a problem. So what kind of trends are you seeing in that area?
That's a great question, Gordon and Natale, if you want to weigh in as well. But I think that's part of the goal of Trusted Profile Analyzer, Trusted Artifact Signer, and the ability to integrate them not just in Red Hat tools, but in other tools that a developer might be using. So Profile Analyzer, and as well as OpenShift dev spaces, things that can be integrated with the IDE and with other tools that developers use every day. But
yeah, plus one on this, and I think the more those tools are integrated with the developer ecosystem, the better it is. If it is an extension in the IDEs, then it's familiar. No, it's very hands-on to install and configure it. And security shouldn't be another piece to add more cognitive load on the developer, which AI platform, too much, right? But if we are able to automate this and we comes to developer close to their tools, like an extension, or here's the right-base image you shall use, because it's signed with the GPG key and health index and so on. Those are the dependencies you should use. If we come closer to developers, then it's easier for them to integrate and adopt security practices.
We develop an operator, as you know, Natale, which is Cloud Native PG, and we have a private version, blah, 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 whatever. We have a lot of customers, and one of the issues that we usually have in this profiling and security stuff is that usually we need to rely on the UBI images, right? Because it's Red Hat compliance and OpenShift and everything. The problem in the main issue here is that you are talking about analyzing CVEs and everything, that is nice, but what about what is actually running on the image and is not being used? But sadly, the images are categorized as highly vulnerabilities and stuff like that because, I don't know, this example will be, I don't know, set a leave in some package that is being used, but we are an operator, so we don't have that. Or probably you have the UBI minimal images that are micro is the smaller one, yeah, micro one, and sometimes there's some issues there, but this Go version that is running is compiled statically, it's not using the living size, kind of weird. So is there any way that OpenShift is going to provide some kind of interface that will say to the customers and the users, hey, this image it has these CVEs, but you are not affected by these CVEs because you are not running these binary files. Is that something that is working on? Because it's kind of hard to get this, hey, your image is dangerous. No, it's not. You're not using this.
That's a really great question. And as you mentioned, there are different sizes of UBIs, but even, not everybody can use micro. Even minimal has some package content that is kind of subject to challenges. So there are kind of two things happening. One, ensuring that, our Red Hat product security team has invested in moving from sharing CVE data via what was called OVAL to VEX, so that we can have more metadata available, which means our solutions can surface what Red Hat knows about whether the package is affected in UBI, et cetera. But the other thing is we have a team working on internal tooling first to do testing in our CI, because our teams have this challenge as well, right? So we're building operators with UBI, and sometimes there's a package in that operator that has a known vulnerability, but it's not called by the code, right? So we want to be sure that we can, in our pipeline, assess those paths and provide guidance to our dev teams. And I think once we get to a place where we can do that internally, we'll be able to share that externally with our customers. Is that the kind of thing you're looking for?
Yes, thank you. I have another question. You mentioned the signatures and the S-bombs in the containers images. Is this something that is planned to be enforced for operators and operating images in OpenShift during the future? Because we're already providing the proper S-bombs and signatures for the images, but right now it's not something that is being used that much. I can see we have issues with the OpenSSF Foundation because they are checking for S-bomb with the name, but no one is looking for the S-bomb inside the image. Is that something that's going to be enforced and required in the future?
So I've seen regulations requiring S-bombs for any packages, for any software that's consumed by different governments. I have not yet seen a lot of enforcement of that. I'll have to check on when that might land. I actually have been working with S-bombs for a long time. I helped contribute to SPDX 1.0. Don't shoot me if you hate SPDX. It is a bit of a challenge. So I will say Red Hat is committed to providing S-bombs for our content. There is a beta version of those available today. If you Google Red Hat SPDX beta, you can probably find the link. And we'll be, moving to make that GA. And of course, we provide signatures for everything we ship, and we have admission tools that can check those signatures. One of the challenges, if you work with OC Mirror, there have been issues with the signatures with mirroring. We're working, I believe that's been addressed in a recent release, right? It's something that we want to make easier. Whether organizations, there was a lot of stir around SigStore when it first came out, but I have yet to see a huge adoption. So I don't know really how that's going to play out in the industry. Our goal is to make it possible because we want to help our customers if they, feel that they can prevent things like SolarWinds hack. And so in terms of enforcement, it's unpredictable at this point. Yeah.
Thank you.
Yeah, thank you. Hi, Kirsten. This is Krishna. I work for Korber Pharma. This is for my customers. The question come from my customers directly. As you know, one of the important things with OpenShift is most often customers complain is about the resource utilization, right? You need high number of CPUs compared to the vanilla Kubernetes. So that's one thing I always hear. And when I started working in ACS, I think 5 years ago when OpenShift acquired StackRock, right? And you still need a lot of resources for that. And I hope there is a lot of work going on. Another question is about, what about observability, right? Customers often still feel that, hey, OpenShift comes with matrices collector, but then you have to have OpenShift observability separately installed, etc. Is there any work happening there to fine-tune that, optimize it?
So
or bring it like one single operator so that customers can directly.
So a single operator that combines the monitoring solution and the observability, is that what you're thinking? Yeah. The challenge, I think, with going that direction would be, in fact, the increased footprint and utilization. So kind of at the moment, having those split, right, the monitoring, the built-in monitoring is something that we use for all the platform components, for health and liveness probes, and ACM is able to leverage that across clusters. Observability, what we've seen so far is that there are organizations, our customers, some of whom use a different and external observability platform. So I would be concerned about combining those two pieces into a single operator, that it might in fact not necessarily help with resources, et cetera. And we mentioned Edge, or I mentioned Edge at the end there. We know that for ACS, the footprint is currently too big for some edge environments. Edge means many different things. So I think it's a balancing act, and our goal is to make things available, but really minimize what's required.
Yeah, I understood that. Thanks for that. Why I said that in specific, because when I tell customers to use OpenShift, they'll say, hey, what are the options we have to, by the way, our software is based on Kubernetes, right? So we recommend customers to start using Kubernetes, and they will be like, hey, does anyone support Kubernetes? And said, okay, go with OpenShift or other providers. Then they ask, what is the benefit of using OpenShift? So one thing we'll always say is that it comes with pre-built observability, pre-built security, et cetera, et cetera. Then we tell customers to use Dynatrace or Datadog. They'll be like, oh, that's an additional cost.
So definitely, if you have observability requirements, let's connect afterwards. We can, I'll feed them back to the observability team so that we can look into that. And again, it's sort of like we have to figure out how do we enable a broad set of customers without leaving some set aside. The other thing about the term observability is that, like security, it means a lot of different things, right? And so it's always important to get to use cases, logging and auditing. Like audit logs are built into OpenShift. So for me, and I'm sure you do this, but I would be having the conversation at the use case level and I'd love to hear from you more specific use cases that we can share back with the observability team.
Thank you. And this was just like a first suggestion. Thanks very much.
Okay, I have another question related to, you mentioned the OC mirror at the end of your answer. Okay, there's an issue that we are experiencing in the past, and well, actually not in the past, probably in the future too. It's that people usually have issues with the multi-arch images, and OCI mirror, sometimes it has this kind of issues that it's pulling the wrong image because it's pulling the image of your local architecture, but not the image of your cluster. Meaning that if you are running, for example, x86 or Mac OS, the new model with the ARM stuff, and your cluster is in S390X, it's kind of issue. This is something that is being added to the bugs report, because I've seen some bug reports on this, but never seen a fix.
I appreciate you flagging it. We will definitely, I'll look for bugs. That's something that if we have not already fixed, definitely we should be addressing. So I appreciate you flagging it. I had not myself heard it before, but I'll find the issue and we'll follow up with the team.
It's a good one. Maybe the one reason why it's not raised yet, because those production installation comes often from a Bastion host, not from the laptop or the workstation, right? So it's a VM or RHEL VM that's at the same architecture of the target cluster. That's why maybe they haven't seen too many use cases like this, but this is a good one.
Exactly, that's one of the use cases. Why is important? Because when you mentioned this is what's related to the SBOMs, and we are distributing the SBOM per architecture. So if you are pulling the wrong architecture, you are pulling the wrong SBOM. And in different architectures, for example, x86 and S390X, the SBOM is totally different. So that's why it matters.
Yeah. No, it's a good point. And I believe, we have on the ACS scanning backlog today, you may have to input an architecture switch, but we want to make that something also where ACS can discover. So it's something that I've heard in other contexts. So I appreciate you raising it here. I'll follow up.
This is quite a historical question, and I think it's still relevant today. Quite often, a lot of our customers ask about the swear word in the room, antivirus. And obviously, we're talking immutable operating systems and containers that are built and can't be changed and things like that. But how do we go about justifying that we can't put antivirus on this stuff? That is always a challenge.
Yes, it is. I have a multi-part response to that. So first, as I'm sure you're aware, there are a number of regulations, including PCI DSS, that explicitly mention antivirus. So it's not unusual for a regulation to prescribe an implementation rather than describe the use case they want to work to prevent. And that's the case both with PCI DSS and some other regulations I can think of in the telco space. So we actually do have a white paper. If you ping me after the session, I'll get you a white paper that talks about the different approaches you can use around to address the concerns with antivirus. Typically, you know, some of whether that's accepted or not is partly going to depend on your auditor, typically. The other part to the answer is that RHEL Core OS, for the operating system level antivirus scanning, RHEL Core OS has been adding a functionality called layering. Today, it makes it easier to add content to RHEL Core OS in an automated way. Today, you can do that at the image. You can kind of build a custom RHEL Core OS image now. So if you have an antivirus solution that works with RHEL Core OS, typically with this approach, because a lot of them, if it works with RHEL, you can add the RPM or whatever that's needed to RHEL Core OS. And we're adding what's called on-cluster layering so that you can also do that on a running node. Now, it may, in fact, require a reboot, et cetera. But so we've really been tackling that in both of those directions.